Welcome student. Today's topic of discussion is measurement. As already we know, physics is a science of measurement. So measurement is that operation by which we compare a physical quantity with unit chosen for that quantity. The process of measurement is basically a comparison process. The measurement of a quantity is mentioned in two parts. The first part gives how many times of the standard unit, and the second part gives the name of the unit. For example, say length of the room is 7 meter. It means 7 is the number and m is the meter. So it means it's the 7 times of 1 meter. And what is the need of measurement? As we know, in science and engineering, we perform experiment. During experiment, we have to take reading. Thus, all this experiment require some measurement to be made. The measurement are necessary for production and quality control also, and experimental verification of laws and theories also need measurement of physical properties. Now, I'll discuss about the least count, accuracy and precision of measuring instrument. So, what is least count? Generally, when we measure any physical quantity, we use any instrument, and the smallest value that can be measured by the measuring instrument is called the least count of the resolution. Say for example, we use vernier calipers, and it has a least count of 0.01 centimeter, and a speedometer may have a least count of 0.001 centimeter. And what is the accuracy? It refers to the closeness of measurement to the true value of the physical quantity. And what is the precision? Precision is the degree of exactness of measurement. Basically, it describes the limitation of the measuring instrument. So, in this diagram, say a measurement 5.382 meter. One student is measuring a length 5.382 meter, and then another student is measuring another length, say 5.3, same length measuring 5.3. It means first student make more precise or more accurate measurement. This is why? Because it's 5.382. So in this diagram, you see in first figure represent good accuracy and good precision, because all the error at the same point at the red mark. In second measurement, there is a poor accuracy but precision is good. In third diagram, accuracy is also poor and precision is also poor. Now, types of measurement. So, depending upon the method of measurement are classified into two types. One is direct measurement, another is indirect measurement. So, what is direct measurement? When measurement are taken directly using a stool, instrument or other calibrating measuring device, they are called direct measurement. For example, when you measure the length of a room by using a meter scale, it means it's a direct measurement. And when the measurement must be done through a formula or other calculation, the measurement called indirect measurement. For example, when you want to measure the radius of the sun, so you cannot directly measure the radius of the sun. You require a formula. By using formula, we can measure the radius of the sun. So this means it's an indirect measurement. Now, in every measurement, whenever we measure a physical quantity, there is error associated within the measurement. Error may occur due to different reasons. Generally, error are classified in three types. Types of error are three types. So, the error in measurement can be classified as a systematic error, a random error, and gross error. So, what is systematic error? These errors are that tend to be in one direction, either positive or negative. Basically, these are the error whose cause are known. Source of systematic error may be instrumental error. It means whenever you use any instrument, it means instrument may be wrong or instrument is not correctly marked. These are the instrumental error. And another error is imperfection in experimental technique or procedure. Whenever you are measuring anything, if procedure is wrong, it means there must be an error. And personal error, and it is a personal error. It can be minimized if you measure too many times. And random error. What is the random error? The random error are those errors which occurs irregularly, hence are random with respect to sign and size, and these can arise due to random and unpredictable fluctuation in the experimental condition. Personal error by the observer taking reading, etc. When the same person repeats the same observation, it is very likely that he may get different readings every time. Now, how you can calculate the error? There are there are lots of procedure. One is absolute error, relative error, percentage error. First, absolute error. The magnitude of the difference between the true value of a quantity and the individual measurement value is called the absolute error of measurement. This is denoted by delta A. Let the values obtained in several measurements are A1, A2, A3, an. The arithmetic mean of these values is the true value. So arithmetic mean is the sum of the total measurement divided by number of measurement. Then error in individual measurement. So in first measurement the error is del A1. So what is del A1? Del A1 is the difference between true value and measure value. True value is A mean average value minus A1. Similarly A2 is A mean minus A2. Like this we can write del AN is equal to A mean minus AN. The del A calculated above may be positive or negative, but absolute error del A will always be positive. Now, mean absolute error. The arithmetic mean of all the absolute error is taken as the final or mean absolute error of the value of physical quantity. It is represented by del A mean. In last time we have seen that the error in first quantity, absolute error in first measurement is del A1. Similarly for second is del A2, like this del A3 del AN. So mean absolute error is the sum of this absolute error divided by total number of observation. So this can be written like this, summation of del AI by N, where N is the total number of observation and I is 1 to N. Now relative error. It is the ratio of the mean absolute error to the true value. So relative error, what is relative error? Relative error is the ratio. It is the ratio of mean absolute error and the arithmetic error to the true value. So del A mean divided by true value. We have taken true value is the mean, so divided by A mean. Now what is percentage error? So when the relative error expressed in percentage, it is called percentage error. So percentage error is equal to a mean absolute error divided by true value into 100 is the percentage error. Now propagations of error. Generally when we measure two or more quantity, if we add or multiply or divide, then what will be the error, resultant error. So first I will discuss about the error of sum or difference. When two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute error in the individual quantities. So let us discuss this topic. Say let two physical quantities, say one physical quantity is A and another physical quantity is B. Its measure value is A plus minus del A. Why plus minus del A? Because error may be positive or may be negative. So the measured value of B is B plus minus del B. Then what is the del A and del B? Del B is the absolute error of A and B. In the case of measuring of A and B, del A and del B are the absolute error. So we used to find the error in del Z, that is in sum. So Z is equal to A plus B. Put the value of A and B, then Z plus minus del Z is equal to A plus minus del A plus B plus minus del B. The maximum possible error will be del Z is equal to del A plus del B. Similarly, for difference, say if Z is A minus B, then put the value of A and B, we can calculate and we can prove or we can get the maximum value of error in difference also is del A plus del B. Now, error of a product or a quotient. When two quantities are multiplied or divided, the relative error in the result is the sum of the relative error in the multiplier. So let Z is a product of two quantities, say one is A and another one is B. If we measure the value of A is A plus minus del A and B is B plus minus del B, then Z is equal to Z plus minus del Z is equal to, put the value of A and put the value of B, then calculate and divide left hand side by Z and right hand side by AB. Then we have 1 plus minus del Z by Z and plus is equal to 1 plus minus del A by del A and plus minus del B by del B, like this. So finally we will get the hence maximum relative error is del Z by Z is equal to del A by A plus del B by del B. Del B by del B by B. So basically it means in product or in equation, the relative error in the result is the sum of the relative error in the multipliers. Similarly, you can easily verify that this is true for division also. Now error in the case of quantity raised to a power. The relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. Say, suppose z is a to the power k, then what will be the error in z? So error in the z, relative error of the z is del z by z is equal to k times of relative error of a, del a by a. So in general, we can write the formula z is equal to a to the power p, b to the power q and c to the power r. So relative error in z is equal to del z by z, and this is the relative error of z, and relative error of a is p into del a by del a by a and plus q into del b by b and plus r into del c by c. Now I will discuss about the significant figure. In any measurement, the uncertainty in the experimental or the calculated values is indicated by mentioning the number or significant figure. The significant figure are meaningful digits which are known with uncertainty. There are some rules for determining the number of significant figures. Now I will discuss about the rules for determining the significant figure. Now first rule is all non-zero digits are significant. All non-zero digit means, say one digit is 4 to 8.3. So in this case significant figure is 4. Why 4? Because there is no zero. So all non-zero digits are significant. Now rules number 2, zeros preceding to first non-zero digit are not significant. So in one example, say 0.05. In this case significant figure is 1. Why? Because 0 preceding to non-zero is not significant. Similarly for 0.045 the significant figure is 2, and 0 between two non-zero quantities must be significant. So say 3.006, in this case total significant figure is 4. Why? Because 0 is lying between two non-zero digits 3 and 6. Next, zeros at the end or right of the number are significant provided they are on the right side of the decimal point. For example, 0.200 gram has 3 significant figures, but if otherwise the terminal zeros are not significant. If there is no decimal point, for example, say 100, in this case significant figure is 1, but 100.00 has 4 significant figures. And similarly, in the case of addition and subtraction, the result should be reported to the same number of decimal place as that of the number with minimum number of decimal place. For example, we have added here 3 number, one is 14.11, another is 16.0 plus 2.012. The result is 32.122. As 16 have only one digit after the decimal point, therefore the result will be 32.1, one digit after the decimal point. This is the rules for addition and subtraction. And in the case of multiplication or division, the result should be reported to the same number of significant figure as that of number with the minimum significant figure. In this case, we have given one example, say 2.3 into 1.45 is equal to 3.335. Answer will be 3.3 because 2.3 have 2 significant figures. The result should not have more than 2 significant figures. So these are the today's topic. So thank you everyone.